I'm here to talk to you about a Alan Turing Institute funded project called EnergyFlex, which I've been working on for the past year, which has been a collaboration between the University of Cambridge, University of Leeds, and DAFNI, where we've been hosting some of the model components. Now, the idea with this was essentially to build a synthetic housing stock for any local authority in the country that we could use to consider some of the decarbonisation and energy efficiency strategies that would be best suited to the housing in that local authority. So this afternoon I'm going to talk about a couple of things. Obviously a little bit about who we are and why we've built this, a little bit about how it actually works, and then obviously, as Brian said this morning, this is very much about sort of use cases and how DAFNI is getting used and what it can be used for. So we're going to look at two use cases for EnergyFlex. But first, a little bit about the team I mentioned. This is a collaboration between Leeds, Cambridge, and we've had DAFNI involved from early on, which has been really useful to actually ensure that we've made the most of using the platform. The sort of inter-university collaboration is also quite important to this project. We bring together expertise in sort of energy modeling, urban energy modeling and uncertainty with some of the spatial modeling expertise that the team at Leeds had. So this was pretty important that we sort of spliced together two rather different approaches to build EnergyFlex. Now, there were sort of two sides to the motivation for this project. On the one hand, there's probably the slightly obvious argument around decarbonizing, the need to decarbonize residential energy demand. So you may well be aware of the statistic, but about 10% of carbon emissions in the UK are associated with heating our homes. So that's quite a big chunk of the pie. And the issue is that coming up with solutions to effectively decarbonize that chunk of the pie, to improve the energy efficiency and reduce the carbon emissions of heating in homes, requires sort of household by household solutions, a case by case basis. But the household level data that we have, either we don't have it, or when we do have it, it's often not detailed enough. And so our idea with EnergyFlex was a microsimulation based solution to that problem, essentially the ability to generate synthetic households for a local authority to identify possible solutions. Now, the name, you may be wondering where the names come from, and actually our original idea with this was to look at flexibility in demand within a local area, and we haven't quite gotten to that yet, because we actually realized partway along the journey that it had this other really useful side, which was targeting local authorities and housing types in need of energy efficiency improvements, retrofits, so on and so forth. But there's another side to our motivation, which is a little bit more academic, and for those of you who've worked in research and modeling in the room, certainly on the energy and building simulation side, you may be familiar with this, which is that we often rely on either assumptions or data that we have to sort of go cap in hand begging for when we want data on a localized area or sort of specific characteristics of housing stock that we want to simulate. And obviously both of these have their issues. And so this was actually sort of the other side of the coin in terms of us working in research in building simulation, having a basis for making slightly better or slightly more informed assumptions or sort of another source of input data was really useful. So in terms of what EnergyFlex actually is, there's a couple of steps to it, and I'll explain those in a minute. But essentially, we started out from the point of view that we wanted to use as much public data as possible and to rely on public data to the furthest extent possible so that anybody could use this and that there'd be no privacy concerns or GDPR issues with the data we generate in the synthetic population. So we start with that public data, creating a synthetic population of houses and the households that live in them that's representative for a local area. We can then use energy modeling to estimate some of the energy efficiency and energy performance characteristics of those houses. And the fact that we have those socioeconomic characteristics of the household and sort of the technical energy performance characteristics of the building allow us to carry out some rather intricate policy and retrofit solution simulations, and it's almost like a sandbox, really. You can play around with it, you can try different ideas and see what the impact would be for that local authority. Now, at this point, we often get asked about the EPCs, which are the energy performance certificates. And if you've bought, rented, or sold a home since 2008, you will have almost certainly seen one of these. And if you didn't, you should have probably asked the estate agent for one. They should have provided you with one. Essentially, it's much like on the back of your fridge, tells you how efficient your home is, and it provides a little bit of information about the construction of the house, sort of whether it's average or better or worse performing, the windows, the walls, etc. So why can't we just use this data when we want to get some inputs on the local area for our modeling? Well, first of all, it's a biased record, right? It's only been a requirement to have one since 2008, so the sample of EPCs only includes buildings which have been sold or rented since 2008. In addition, there's this additional issue, which is it's not actually always that accurate. So even the full EPC record, they're humans who are doing these evaluations, and there's often approximations and mistakes. There's also no information on socioeconomic context, which actually, basically, you're only seeing one side of the picture, right? You see the technical performance of the building, but you don't see the other side of the sort of socioeconomic context of the household that lives in that house. And finally, from a research perspective, EPCs are not anonymous. There's an address, you can actually go and find it. So there'd be a lot of concerns if you actually wanted to do any sort of scenario simulation with this kind of data. That being said, the actual structure of EnergyFlex, there's sort of three key blocks to it. There's a population synthesis step, which our colleagues at the University of Leeds took the lead on using their Spencer model. And there's two energy characteristic estimation steps. There's the intensity estimation, where we group houses by their age and type, so whether it's a flat, semi-detached house, terraced house, etc. And these first two steps allow us to have a synthetic population of households and the houses they live in with an estimation of their annual energy consumption. All of this is possible using public data only. If we have a sample of case study data from a local area, we can actually use a Bayesian calibration approach to estimate some of the building fabric characteristics which allow us to evaluate some of those policies and retrofit solutions. And now on to where DAFNI fits into this, actually, because obviously DAFNI has provided us with a useful cloud-based platform, if you will, for scheduling modeling runs and sort of crunching numbers for the whole country, which is obviously quite useful. But the other side of this is actually engaging with stakeholders. It can sometimes be a little bit difficult because they come to you with a question, essentially, and they're like, well, that model sounds really interesting, but I'd like to look at, this part of Leeds or Newcastle or wherever it is that they're interested in, and you're not working on that. So then there's a question of actually, if you don't have the time to put in, sometimes you end up not following up on those leads. And where we found DAFNI really useful is actually we can package it up and obviously put it on DAFNI, and that allows us to share it with other researchers and even sort of people working in local government or interested in housing in general. And all they have to do is specify an input parameter, in this case the local authority they're interested in, and they can run the model and get the output file themselves. So this is what we've been really interested in. We're not quite there with actually getting anybody to use it yet, although we've packaged it up to this point. But this is sort of one of the ways that we see DAFNI being really helpful to us going forwards. Now, I talked about use case, and this is maybe the most interesting part. We're going to start with a use case looking at how we've used EnergyFlex to look at trends across the whole country. And what this map shows us is the energy intensity of new build homes built since 2000. So the darker blue tiles on the map represent local authorities in England that are have quite low energy intensities on average for their new builds, and obviously yellow and red slightly worse performing households. And what's interesting is that we found quite a significant correlation, and obviously correlation doesn't imply causation, but we find very interesting correlations with house prices and disposable incomes, as well as a slight correlation as well with average or heating degree days, not average temperatures. But this kind of analysis can be really useful for identifying perhaps parts of the country in need of further support. But we can actually take this a step further and look within local authority to local authority. We can look at, for each housing type and each age of housing, how efficient the homes in that local authority are, and it helps us to identify, for example, in Leeds we see that a lot of the oldest homes are actually quite a bit more efficient than comparable homes in surrounding local authorities, and there's a whole range of reasons why that may be. It may be that there's a higher proportion of retrofits already. It's very much a back-of-the-envelope calculation rather than a final decision-making tool, but it allows for that high-level view. But we can zoom in much further, and this is sort of the second use case, which is looking at simulating retrofit solutions. So we worked with the Borough of Haringey in London, who supplied us with a little bit of extra data to allow us to do that final step and estimate some of the building performance characteristics beyond just the intensity, the energy intensity. So Haringey is interesting because it's almost, the housing stock is almost entirely made up of flats, and most of them were built before 2000. So let's say we want to look at a question, say we're interested in inefficient heating systems. It's a very topical thing, replacing boilers with air source heat pumps, sort of topic of the moment. So let's say we're interested in that. Now, using EnergyFlex, we can actually estimate the likely efficiencies of the heating systems in these different age bands of flats in Haringey. And in this particular example, we find that actually some of the most inefficient boilers are to be found in the 1930s to 1970s flats and 1970s to 2000s flats. Okay, that's interesting. That's already a bit of a start. We can identify types of house that are to be targeted or would be beneficial to target for heating system improvements. But we can then actually look at who's living in these houses, right? And that's where the other side of this comes in. So actually we find that in the 1970s to 2000s flats, we see the highest proportion of, in Haringey, of households in lower socioeconomic groups. And we see that a lot of those 1970s to 2000s flats are actually social rentals. Interestingly, the 1930s to 1970s flats are mostly private rentals. So what does this all mean, though, when we're sort of looking at the big picture, sort of simulating our policy? Let's say we are interested in replacing those inefficient boilers with heat pumps, just for example. Well, the higher prevalence of inefficient boilers in the 1930s to 2000s flats would probably be a good place to start, just because there is a high proportion of inefficient boilers there. It's low-hanging fruit. But there's a few things to know. Obviously, the households in the 1970s to 2000s flats, we noted that they're probably in lower socioeconomic groups, and they may be more likely to need financial support if the household was made to bear the cost of any improvements. Similarly, in the case of the 1930s to 1970s flats, what this would tell us actually is that we probably have to find some way of incentivizing, or more likely forcing, private landlords to upgrade their heating. Now, thank you very much for listening. Obviously, if you are interested in this, you can get in touch with me. I don't work for the University of Cambridge anymore, so yeah, do contact me at my new email address. But you can also find some of the code on GitHub, and we are working to publish a few aspects of this. And if you are interested in using this on DAFNI, do get in touch. We're always looking for people who might be interested in using this. So thank you very much.
Okay, thanks very much.